Hope you are doing really great. So welcome back to my Tech Stack Learning channel. Today's session is majorly on the transform chains on the LangChain. So I had a series of sessions on the LangChain. If you haven't watched, please go ahead and watch. It is available under my playlist called LangChain Mastery. So today's is majorly on the transform chains, where we will see practically how what are the features it has, what are the different types of use cases we can develop, and how to allow to pre-process and post-process the output when using LLMs or other chains, right? So I'll give you a complete deep dive with all possible concepts, including the code examples and the explanations. Stay tuned till the end of the session. So what is transform chains, right? It's basically in LangChain lets you apply some of the arbitrary Python functions, right? So what happens here is you inputs whatever, sending them to the LLM, right? Like before sending it to the LLM, that is, we call it as a pre-processing, and after what we get once the LLM is done, right? That is called as a post-processing, correct? So think of it as like a data pipeline step, like inside your chain, to process or transform your data responses pre and post or in between, right? So why to use this transform chains is basically it helps to clean and normalize input. Like there will be scenarios we'll have to remove some kind of stop words, or you may have to convert that into a lowercase, right? So for that, transform helps. Okay, then if you want to add extra metadata before sending it to the LLM, like in case if you have any kind of images, or if you have to add any kind of keywords, then you can use this transform, right? Then post process outputs, like if you want to extract or format or clean the formatting, right? So that is where the another area where we use the transform chains, and then use custom logic in the middle of the workflow. Like need not to be just an LLM, right? It could be a mix of LLM and non-LLM logic, right? It could be a simple lowercase, which we don't need LLM. If you want to use a simple Python functions, you can use this transform chains to do that activity. Okay, so now let's see the actual live coding on how, what all the things or the features or what all things use cases we can develop using this transform chain, right? So let me create one file called thought.py. I will just copy the base required uh, modules. Okay, so let me, this is required prompt template, let it be. We'll remove all this. Okay, we don't need this now. If required, we can import it later. Okay, prompt template, let it be. So these are the default imports which I need for now. So apart from this, I need, I will first check the basic pre-processing with transform chain. Okay, so here we will do we will import a module called transform chain, which is given by LangChain's LangChain module. Okay, so import transform chain. uh, then what we will have to do is we'll have to define the function first, like define transform function first. This is not custom, right? So it's not like inbuilt any LM or things. It's like a using a function to do something in between, right? So I have created one lowercase function. Okay, then I'll put the input. I'll take the input. Then here basically what it does, it convert input text to lowercase before passing it forward, right? So this is what it does. and then I'll say text equal to, then I'll take the input, the variables which I get it is in the text. Okay, then I'll return what the lowercase processed text. So it will be text dot lower, right? This is a simple function, right? Now what I'll have to do is I have to build a transform chain, correct? So here I'll have lowercase chain equal to transform chain, and here input variable is what? It would be the text. That is what my input will be, right? So text, then I will have output variables which will be, this is what it is returning, right? This is what it is returning, pre-processed text, correct? Then what I'll do, I'll use the transform function, correct? This is my transform function. Okay, now let's try to print lowercase chain dot run of, I'll put hello world. Okay, and you should see all the output which is giving it is in a lowercase, right? So Python transform, invalid syntax, yes. Okay, you can see it has given it as lowercase, right? This is the basic pre-processing, like where it takes the text as an input, return the process text with lowercase, and useful for the pre-processing steps, right? That is where this simple one helps, correct? So now we will see how it works on the post-processing, right? So what we will do here is we will run an LangChain and then strip the extra spaces or punctuations using the transform, right? So what I'll do now, I'm just going to comment this off. Okay, we don't need this right now. So I will need this import anyways, right? And also I have the prompt template defined. In addition to this, uh, LLM chain and the sequential chain, right? So LangChain dot chains import LLM chain sequential chain. Okay, so I need these two additional inputs in the prompt template. Okay, this I can place it here for easy understanding. What I can do, I'll just put I'll remove this. This is for basic, right? So now what I'll do is I'll put a comment post processing. Okay, okay, post processing example. So I have imported this, and then what I'll do is I'll create a summarize chain. Okay, prompt equal to prompt template dot from template of, then I'll put summarize in one line, then I'll place my text. Okay, this is my prompt. Then I'll create summarizer chain equal to LLM chain dot LLM equal to LLM, then prompt equal to prompt, then output key equal to summary. Okay, so this is my simple summarizer chain. Okay, now what I'll do here is I'll define post process transform. Okay, so this is basically for post processing. Like pre-processing we have seen, now we will see for how we can do for the post processing. Now what I'm trying to do is, if there is an extra spaces or the periods, then I'm trying to remove from the LLM response, right? So I'll put clean summary input will be dictionary, then we will have dict colon, then I will say summary equal to inputs of um, summary. Okay, this is what it is. I'll strip it off, then I will write strip of dot. Okay, then return what? Return. I'll pass the variable as clean summary, then I'll have summary, right? Okay, so this is what my function is, and now what I'll do here is I will just copy paste this. I can create, it's okay. So I'll put post process chain equal to transform chain of input variables equal to this is my input which going to my transformer, that is basically post process, right? Then output variables will be my uh, clean summary, then transform will be my clean summary function. Okay, now I'll have to combine this with the sequential chain. Right? So I'll create like variable called pipeline, then sequential chain of, I have two chains here. So I'll have first summarizer chain, then I have post process chain, correct? Then input variable for this chain will be my text, right? Whatever I'm passing for the summarization. Output variable will be what? It will be clean summary, right? So it will be clean summary. Okay, I will also enable the verbose. Okay, so we have combined it. Now let's run this pipeline and see how is it working. Okay, so print of pipeline dot run of LangChain makes easier to build applications with LLMs. Okay, let's run and see if we are encountering any issues. So what we will do here is, yes, it's entering the new sequential chain. What does it do? It will first is get the summary, and then it will be cleaning up the responses using the post process chain, right? So this is the another example of post process, how we can use the transform chain, right? So we will see another example of multivariable transform, right? Like we saw only this uh, pre-process, which we are just converting into the like lowercase or things, right? Now we will see an example of multivariable transform. Okay, basically feature extraction. So transform chains can add new variables within it, right? So here what I'll do here is I'll just create one function called extract features. Input will be whatever I'm passing in dictionary format, and then here, then what I'll do here is text will be whatever I have been inputting as a user, right? uh, then I will have return. What I'm going to return here is three things. One, whatever the user input, whatever user has given. Second, word count. Okay, word count. which will be basically length of text dot split, right? And then we will have character count, which will be basically length of text, right? So these are the three variables which I'm going to extract and send it back as part of the transformation, right? So here what I'll do here, I'll create another chain called feature chain. Then here input will be always my text, right? So it will be text. Then output variables will be what all we will have. There will be three outputs. One is text, right? Another one is word count. Then we have cat count. Okay. Then we have transform equal to extract features. Okay. Then we will call the feature chain dot invoke of, we will say LangChain is awesome. Okay, let's see what is it giving. So for now what I'll do here is I'll just comment all of this which we don't need, right? I'll just run only the multivariable feature. So here it should give you the output. It has what it is giving, tuple object. Why invoke? Where is it? What is the issue? Self transform and extract word count. Word count, what is the issue? Length of text split. I don't know if that is a cause. Let's see. Yeah, that's the comma was an issue. It has given word count 3, character count 19, right? This is the another example of using multivariable transformation. Like it's very useful if you want to extract few things in between, right? So that is about the multi-transformer. So if you have to see the anything something related to the JSON, right? So I'll create another one for JSON processing, right? JSON post processing, like LLMs often return unstructured text, right? You can just use transform chain to extract the structured JSON. So JSON post processing. So here I will do import JSON. Then we will create another function called extract JSON. Here I will be having input dict. Then I'll have dict. Then raw equal to input raw output. Okay, then I'll put try catch here. Data equal to JSON dot loads of raw. Okay, then accept data equal to, if there is any error, right, then I'll say invalid JSON. Okay, so what I'll do here, I'll just return past output colon data, right? So what I'll do now here is I'll just create another chain called JSON chain, which will have transform chain, then input variables equal to is a raw output. Okay, then I will have output variables equal to parsed output. Then we will have transform is equal to extract JSON. Extract JSON. Okay, then I'll do here print. I'll call JSON chain dot run of. I'll use, I have a sample JSON. Let me just copy paste that. Okay, let's see how is it going. So it will basically converts the raw text into a Python dictionary and then handles the errors gracefully. Okay, let me comment this out for now and let's run it. Import. Oh, that's something I should have noted it. Again, it is telling some error row output. It's a error. Yeah, it has converted this into a proper JSON structure, right? So that is another sample examples of using it, right? So another one we can think of is parallel use with map reduce, like chunk processing, right? So what I'll do here, just comment this, okay, and I'll create another function called split text of inputs dict. Then I'll put dict of, then I'll say text is equal to same inputs of text. Then I will have chunks equal to, then we will have text of, I'm going to split this, okay, plus 50. Then I'll say for I in range of 0 length of text, then I'll say 50. Okay, then I'll say return what? Return chunks. So I'll have chunks, then I'll pass chunks. Okay, my function is ready. So what I'll do, I'll just copy paste the same thing again and I'll just rename this. Okay, I'll have chunk JSON, chunk chain, right? Chunk chain, then transform. Here it will be text, then here it will be chunks. This one I'll go the same thing, then we will have split text. Okay, so now I'll say chunk chain dot run LangChain help. So I have just put just some text here, okay, which I have it. Let's use that. Okay, let's see how is it working. Okay, I have to close this. You can see it has splitted it into a text and then it has given you the responses, right? So that is how it works, and this is the other examples which we have to use for the transform chain. So now let's look at what are the best practices we have to see when we use this transform chains, right? So always declare a correct input variables and output variables, because there would be a scenarios where it might collide, right? Ensure you declare it correctly. Then use transform chains for non-LLM logic in workflows, right? So whenever you have something called non-LLM logic in your workflows, like lowering the strings or getting the keywords or whatever it is, right? Use at that place. Then you can keep transforms pure functions, like no side effects, like input output and there is no side effects, right? So it's very good. And it is mainly used for clean, you can use that for cleaning imports like lowercase, tokenization or chunking, or adding metadata like word count, timestamp, or also parsing up and formatting the outputs, right? This is how you have to follow the best practices. So now we are end of the sessions where we have learned what is transform chains, how to add custom Python logic for pre-post processing, right? Pre-processing mainly for lowercase, chunking, post-processing for the output, and we can combine with the sequential chain with LLMs, right? It's very powerful for hybrid pipelines, LLM plus logic, right? So if you like my session, please go ahead and subscribe to my channel. If you have any specific topic, please put it in the comment box. I can surely try to get you those topics as soon as possible. Thank you and see you in the next session.